Now, in dealing with chemical reactions, there are two major ideas that drive a chemical reaction. Is the formation of a precipitate that drives a chemical reaction, or the formation of a gas. The formation of something molecular, something insoluble, or something gaseous. Now, there are rules relative to the formation of precipitates. Now, as you see this, when you see aqueous, that means it's in the ion form. When you see solid and an arrow down, that means the formation of a precipitate. So the formation of that is actually driving the reaction. Now, these are ions. These are ions. These are not. So if you wrote out the complete ionic equation, you would find this. On the left, do you see that? Let me make the ions in blue, so I don't forget any. Okay? So the left side will be like that. Let me rewrite that. Okay? So it's going to be lead plus nitrate plus sodium plus iodine. Right? And then the ions would be, this is plus 2, this is minus 1, plus 1, minus 1. You see that that's the left. How do you know that? AQ means a water solution. If it's a water solution, the ions are dispersed throughout the medium. Ions are the solute. The water is the solvent. We're going to talk about solutes and solvents in chapter 15-ish. Okay? So, this is a solid. This is not an ion. So this would be like that. And then you have ion plus ion. And you have, this is plus 1, this is minus 1. So what you do is, this is the complete ionic equation. Then what you really do is you cross out the spectator ions. In other words, the ions that are on both sides of the reaction. The nitrate and the sodium are on both sides of the reaction. So they're not really taking part in the reaction. They're not changing chemically. Excuse me?
They cancel each other out.
You know, it's not that they cancel each other out. They're just spectator. They're not part of the actual reaction. They're on both sides. Yeah, I suppose mathematically you could think that you're canceling them out. That's not. I have no problem with that. But they're actually spectator ions. You're canceling out the chemicals that are not entering into the chemical reaction. They're just kind of hanging out. They're on both sides. Right? So what's the net ionic equation? The net ionic equation is going to be the lead plus the iodine, and you're going to form lead iodide. So you're going to take, what is it, and you're going to balance this obviously. What is it that you're going to keep in the chemical reaction? You're going to keep only those chemicals that are part of the chemical reaction. And again, the driving force in this chemical reaction is the formation of the lead iodide precipitate. And maybe I'll do that in the next class. I'll show you how to do that and how obvious it can be. Yeah, easy. All right, that's it. That's all I want to show you. So this is the net ionic equation. Okay. And there are rules in the book that will help you, and you're going to want to put those in your notes so that you can refer them. There are hints, clues, relative to the formation of precipitates. Yeah. Okay? We're off.